Hi guys, welcome to this UKMT Senior Maths Challenge video from the 2018 exam, and today we will be looking at questions 21 to 25. Question 21 says the graph of y equals 1 over x is reflected in the line y equals 1. The resulting image is reflected in the line y equals minus x. What is the equation of the final graph? We got answers as A is y equals minus 1 over x plus 2. B is y equals 1 over x minus 1, C is y equals 1 over x minus 2, D is y equals minus 1 over x minus 1, and E is y equals minus 1 all over x minus 2. So I think the best way to go about these questions is to always draw a sketch of the graph. We know that the curve y equals 1 over x looks something like this. Now I'm going to draw the line y equals 1, which will look something like that. Let's take a point on the graph. Let's take this point here. Say that is xy. We know if we reflect the curve y equals 1 over x in the x-axis, which would be the line y equals 0, all the x values are going to stay the same. The only thing that is going to change is our y values. So what's going to happen is our reflected curve, if I draw it in red, it's going to look something like this. What we know is that when we reflect any function in the x-axis, it's going to be a symmetrical reflection to that function. So, in order for the curve to be symmetrical, the distance from the line y equals 1 needs to be the same for each function. And of course, we know that this point of intersection where it crosses the line y equals 1 must be the point 1, 1. For the curve y equals 1 over x, horizontal asymptote was the line y equals 0. So what's happened here is in order to reflect those asymptotes, surely there is an asymptote here which is 1 unit above the line y equals 1. So that would mean that this curve is now y equals minus 1 over x plus 2. And then what's going to happen is this curve is then reflected in the line y equals minus x, which is that line there. And what's going to happen is all the y values are going to become negative x, and all the x values are going to become negative y. So if we replace this function with y is minus x and x is minus y, let's see what we get. We get minus x equals minus 1 over minus y, which is just going to be 1 over y, plus 2. Then we can multiply both sides by y, and we get minus x y equals 1 plus 2y. And then, of course, all of our answers are in the form of y equals a function of x. So if we move the 2y over to the left-hand side, we're going to get minus xy minus 2y equals 1. Take out a factor of y, it's going to be minus x minus 2 equals 1. And y is going to equal 1 over minus x minus 2. Now what you'll see is there's not actually an answer for y equals minus x over minus 2. But if we take out a factor of minus 1 from the denominator, that's going to be 1 over minus 1 of x plus 2. And of course the 1 divided by minus 1 will just become minus 1. So therefore we will get an answer of y equals minus 1 over x plus 2, which is answer A. Question 22. The diagram shows two overlapping triangles, an isosceles triangle with an angle of 120 degrees, an equilateral triangle with an area of 36. Two of the vertices of the equilateral triangle are midpoints of the equal sides of the isosceles triangle. What is the total area of the shaded region inside the isosceles triangle but outside the equilateral triangle? Got answers as A is 24, B is 26, C is 28, D is 30, and E is 32. Okay, so I'm going to start off this question by labelling all the angles and some of the sides of this triangle. So, because this is an isosceles triangle, and we know that this angle's 120, and these two sides are the same length, then we can say that these two angles are going to be equal. Now, of course, a triangle adds up to 180 degrees, so the sum of both of these angles is going to add up to 60 degrees, so if we divide that by 2, each angle is going to be 30 degrees. Because we know that the vertices of the equilateral triangle intersect with the midpoint of the isosceles triangle, then we know that this smaller triangle here, just above the equilateral triangle, is also isosceles. So we can say that that's going to be 30 degrees, and that is also going to be 30 degrees. And of course, if you divided this in half, that angle would be 60, that angle would also be 60, and then you would have two right angles there. We've got this equilateral triangle, which is made up of three 60-degree angles, so we can fill those in. And now, because we know those two angles, we can find out what these angles are, because it's on a straight line. So these angles are just going to be 90 degrees. It's 30 plus 60, which is 90. It's on a straight line, so the other angle must be 90. So they are right angles. So if they're right angles, we can say that these angles are 60 degrees. And also, because they are alternate angles to this angle here and this angle here. So that is every single angle on the triangle. And what we can do is we can divide this equilateral triangle into three isosceles triangles. If we draw a line going from the intersection to the centre of the equilateral triangle, and then we join another line going down here, you should be able to see 1, 2, 3 makes up three isosceles triangles. So what I'm going to do now is I'm going to have a look at each of these triangles individually. And I'm going to start off with this right angle triangle here. If we label this side as X, and because this is a right angle triangle with 60 and 30 degrees, we can work out this hypotenuse by using trigonometry. Because what it's going to be is it's going to be sine 60 is equal to opposite, which is X, over hypotenuse, which I'm just going to call the hypotenuse at the moment because that's what we're trying to find. And of course, if we rearrange that, the hypotenuse is going to be equal to X divided by sine 60. Now you're probably thinking, well, we don't know what sine 60 is. You should have learnt your trig identities using a right angle triangle, and it's the exact same right angle triangle as we have here. And what we say is the base is 1, the hypotenuse is 2, and the other side is root 3. And then from here you should be able to see that sine 60 equals opposite, which is root 3, divided by the hypotenuse, which is 2, so it's root 3 over 2. So now if we substitute this into this equation here, we're going to get that the hypotenuse is X divided by root 3 divided by 2, which is the same as saying X times 2 over root 3. So the hypotenuse is 2 over root 3x. So we found this side, which is 2 over root 3x. And because it's isosceles, and we know the equilateral triangle shows us where the midpoint is, we know that this length is going to be 2 over root 3x, and also this length is going to be 2 over root 3x. And the same can also be said for the other two sides. And of course I also know that that's x and that is x there. So what I'm going to do next is I'm going to find these lengths here. And of course this is going to be another right angle triangle in which we're going to need to try and find the hypotenuse in terms of x. We've got another triangle where this is 2 over root 3x, and we need to find what the hypotenuse is. So again, we can say that sine 60 is equal to the opposite, which is 2 over root 3x, divided by the hypotenuse. Well, we can rearrange this to get the hypotenuse. The hypotenuse is 2 over root 3x divided by sine 60, which we know is root 3 over 2. Well, if we have a fraction divided by another fraction, that's going to be the same as saying the top fraction multiplied by the reciprocal of the bottom fraction. So we're going to get the hypotenuse is equal to 2 over root 3x multiplied by 2 over root 3, which gives us a hypotenuse of 4/3 x. So, because we know that the angles and the side lengths of each of these triangles are the same, we can say that both of these triangles are congruent. So this length is 4 over 3x, and this length is 4 over 3x. Now, I want to find out what the missing length is. And what you should be able to see is that this smaller isosceles triangle is similar to the whole isosceles triangle. And of course, the smaller isosceles triangle is half the size of the large isosceles triangle. If the base of the smaller isosceles triangle is x plus x, which is 2x, then the whole base of the larger one is going to be 4x, which means that that missing length is going to be 4/3 of x as well. Now what you should be able to see is this bit of the base of the isosceles triangle between the two sides of the equilateral triangle. If we take this result, so we take 4/3 of x and divide it by this length, 2x, well what we can say is that this length of the isosceles triangle is 2/3 of the length of the whole base of the smaller isosceles triangle. What you should be able to see is that the shaded region of the smaller equilateral triangle, if we imagine joining these, it's going to have an area, which is 2/3 times 2/3, so 4/9. So the area of this smaller equilateral triangle is going to be 4/9 of the whole equilateral triangle. 4/9 of the area of the whole triangle, well we know the whole area is 36. So that's going to give us an answer of 16. So the total of the area of this shaded equilateral triangle is equal to the area of this congruent triangle and this congruent triangle. So the only other area left is the area of this top isosceles triangle. Well, we know the area of that isosceles triangle is 1/3 of the whole equilateral triangle. So we do 1/3 times 36, which is 12. And then if we add these areas together, we get a total area of 28, which is answer C. Question 23. For particular real numbers a and b, the function f is defined by function x equals ax plus b and is such that we get this result here. Which of the following formulas defined the function g such that for all values of x, g of function x is equal to x? We got answers as a is 1/3 of x minus 4, b is 1/3 of x plus 4/3, C is 4x minus 3, D is 1/3 of x minus 4/3, and E is 3x minus 4. Now, this function that I've highlighted is basically a composite function within a composite function. So what's happened is we've got this general formula that f of x is equal to ax plus b. And if we find the composite function of f of function x, well, that's just going to be a all multiplied by ax plus b. Now, if we simplify that, we get a squared x plus ab plus b. And now what we need to do is we need to then substitute this function into f of x again to get the result for f of function x. So basically we're going to replace x with ax plus b. And that simplifies to a cubed x plus a squared b plus ab plus b. If we take out a factor of b here, we get b all multiplied by a squared plus a plus 1. And the question says we need to find a formula which defines the function g such that for all values of x, g of function x is equal to x. So we need to find what function g is, basically. So we know that this general formula is equal to 27x minus 52. So what we can do now is we can compare the coefficients. So if we compare the coefficients of x, well that's quite straightforward because we've just got a cubed is equal to 27, which means that a must be 3. And then the other result is going to be this b of a squared plus a plus 1, which is equal to minus 52. Well, that's why I took out a factor of b, because we now know what our value of a is, so we can just substitute value of a in, which is going to be 3 squared, which is 9, plus 3, which is 12, plus 1, which is 13. And that's going to be equal to minus 52. So we're going to get a value for b as minus 4. So now we can substitute our values for a and b into the general formula for function x. which was just ax plus b, so it's going to be 3x minus 4. And of course, we need to find function g, whereby the composite function of g of f of x is equal to x. So what we've basically got is we've basically got another function, if you like, g of x, and we could say that is equal to the same constants of ax plus b, because we've already found what our values of a and b are for the function of f of x. So we use those values again to find two different constants for the function of g of x. We should get an answer. So g of x is ax plus b, and f of x is 3x minus 4. So to find this composite function, we need to replace x from ax plus b with 3x minus 4. So we get a of 3x minus 4 plus b, and of course that's equal to x. And that becomes 3ax minus 4a plus b equals x. And again, what we can do here is we can compare coefficients. So this is going to have a 1 in front of it. So if you like, if we compare the coefficients of x, we're going to have 3a is equal to 1. So a is a third. And then the other coefficients is just going to be minus 4a plus b is equal to 0. There is, of course, no coefficients on the right-hand side. So what we can do is we can rearrange this formula pretty easily to find what b is. So b is equal to 4a and a is a third, so b is going to be equal to 4/3. And now what you can do is we can replace the value of a and b with ax plus b. So a is going to be a third of x and b is 4/3. So therefore that is the function of g, 1/3 of x plus 4/3, which is answer B. Question 24. The diagram shows a circle with centre O which lies in a horizontal plane. The diameter AB has length 4. Point P lies vertically above O, and PO equals 2√2. Point C lies on the semicircular arc AB such that the ratio of the lengths of the arcs AC and CB is 2:1. What is the shortest distance from A to PC? Got answers as A is √2, B is √3, C is 2, D is 2√2, and E is 3. Okay, so let's label the missing lengths on this diagram. We know that O to B is 2, we know O to A is going to be 2, because the diameter of the circle is 4. So we imagine the triangle POC. We know that this bottom length is going to be of radius 2. We know that this height is going to be of 2√2. And using Pythagoras' theorem, we can work out what the hypotenuse is. So we say that PC is the square root of 2√2 squared plus 2 squared. We're going to get 2 times 2, which is 4, and the square root of 2 times the square root of 2, which is 2. So that's going to give us 8 plus 2 squared, which is 4. So PC becomes the square root of 12, which simplifies to 2√3. So the length of PC is 2√3, and what that also means the length of PA is 2√3, which we'll see is this length here. And we can say PB is also 2√3. Because, if you like, there's a line of symmetry going through PO. We're going to have the same lengths, 2√3 on either side. We need to imagine that there's a triangle AOC and COB, because of course we want to find the shortest distance from A to PC. So let's try and find this distance from A to C, because that could turn out to be our shortest distance. So this one's quite easy, because this is basically an isosceles triangle, because both of the sides are of length 2. Now, in the question, we are told that the ratio of the lengths of the arc of AC and CB is in the ratio of 2:1. So what that means, because there's 180 degrees within a semicircle, we can work out what angle AOC is and what angle COB is. Because angle AOC is going to be 180 multiplied by 2/3, which is 120. Therefore COB is going to be 180 times 1/3, which must be 60. So we zoom in on this triangle now, and we know that this is going to have an angle of 120, and that angle there is going to be 60. And then the other thing you should know, going back to circle theorems from GCSE, is that the angles within a semicircle add up to 90 degrees. So this angle here, ACB, is actually going to be equal to 90 degrees. Now, because this is 90 degrees, and we know that triangle AOC is isosceles, which means that where angle A and angle C are going to be the same size. So the total of those two angles is going to be equal to 60 degrees. So we can say that this angle is 30, and so is this angle, which would mean that the remainder of the angle is 60. But we also technically know that the triangle COB is also isosceles because it has both lengths of 2. But because the angles in the triangle add up to 180 degrees and we've got two angles which are 60 degrees, then surely this angle must also be 60 degrees, which means the triangle COB is actually equilateral. So we can say that the length of CB is 2. And now what you'll see is, I'm going to draw another diagram of this because it's getting a bit messy, is if I draw a diagram of the triangle ABC, and we know that's 60 degrees because that's part of our equilateral triangle, and this angle was 30. We said that length is 2, and we know what the length of AB is because that's the diameter of the circle, so that's 4. So now, using Pythagoras' theorem, we can work out the length of AC. AC is going to be equal to the square root of 4 squared minus 2 squared, which is 16 minus 4, which is square root of 12, which we've already worked out as 2 root 3. So length AC is 2 root 3. Okay, so it looks like we're getting the shortest distance to be 2 root 3. But as you can see, there is no answer for 2 root 3. Okay, so we may have not found the shortest distance from A to PC, but now we've got a lot more information to work with, because we've basically found all of the lengths of this triangle PCA. And what you'll find is that we said that the length of PA was 2 root 3, we said the length of PC was 2 root 3, and then we just worked out the length of AC, which is 2 root 3. So the triangle PAC must be equilateral. So I'm going to draw an example of what PAC looks like. That's A, that's C. We know that's 2 root 3, we know that's 2 root 3, and we know that's 2 root 3. So if they've all got the same lengths, we know that the triangles have the same angles because all the side lengths are equal. So we can say that this is 60 degrees, this is 60 degrees, and this is 60 degrees. And now what you should be able to see here is, if you think about it, if you imagine an imaginary dotted line going from point A, and it almost sort of works its way up from the line AC all the way to AP, and from that line you've got to work out what is the shortest distance. The shortest distance would surely be halfway, because if you imagine our equilateral triangle now as two right angle triangles, well, you know that the hypotenuse is always going to be longer than the height of the right angle triangle, so therefore surely the height of either one of these right angle triangles must be our shortest distance from A to PC. So we need to find the length of that height there. So if I call it H, and we now know that this angle is going to be 30 instead of 60. And what we can do is we can use sine. So we can say sine 60 is equal to opposite, which is H, over the hypotenuse, which is 2 root 3. You can rearrange that to get H is 2 root 3 sine 60. Well, we know what sine 60 is because we had to work it out in question 22. And you should remember that that is root 3 over 2. And now if we simplify this, the 2's are going to cancel out, and then you're going to have root 3 times root 3, which is going to be 3. And now, of course, this length is 3. 3 is smaller than 2 root 3. So surely 3 must be our shortest distance. And let's see if we've got an answer for that. And we do, we've got an answer as E. So therefore, our answer is E. Question 25. A semicircle is inscribed in a quarter of a circle as shown. What fraction of the quarter circle is shaded? We got answers as A is a third, B is 1 over root 3, C is 2/3, D is root 3 over 2, and E is 1 over root 2. Okay, so with this question, what I'm going to do is I'm going to label the centre of the semicircle. I'm going to draw two lines to show where the radius just touches the intersection of the two circles. Now, we obviously know that these lengths are going to be the same, so we call these two side lengths as R. Well, we know that this is also going to be r, and this is going to be r because it's a square. And what we can also do is we can imagine a line going from the centre to bottom left vertex of the quarter of the circle, and we can find the length of this as being the hypotenuse of either of these two right angled triangles. So that's easy. We can use Pythagoras' theorem. We can say that that length is going to be the square root of r squared plus r squared, square root of 2r squared, which simplifies to root 2r. Okay, so we know that length is root 2r. And then I thought, right, that's probably as much information we can get from the semicircle. Now let's apply a similar thing to the quarter of the circle, because we want to get the radius of this circle in terms of r. And I think the perfect place to do that is draw a line from the centre to where one of the vertices of the semicircle intersects the quarter of the circle, because we know two of these lengths. We've just calculated this length as root 2 over r, and we know that that bottom length is just r because it's the radius of the semicircle. So we can therefore find the radius of the quarter circle, and if I call this s, then I can say that s is equal to root 2r all squared plus r squared. And that simplifies to 2r squared plus r squared, which is s equals the square root of 3r squared, which simplifies to root 3r. And that is the radius of the quarter semicircle in terms of r. So now we basically got all of our information, because all we need to do now is work out what the area of the quarter circle is and what the area of the semicircle is. So the area of the semicircle is going to be equal to a half pi r squared. Well, we know that the radius is just r, so it's still going to be a half pi r squared. And then the area of the quarter circle is going to be equal to a quarter pi r squared, but our value of r is slightly different. It's actually s, which is root 3r. So we write that as a quarter pi of root 3r all squared. That's going to simplify to a quarter pi of 3r squared, which is of course 3/4 pi r squared. And now what we can do, because the question asks us to find what fraction of the quarter circle is shaded, well, we can divide the area of the semicircle by the total area of the quarter circle. So the area of the semicircle is a half pi r squared, and the area of the quarter circle is 3/4 pi r squared. Well, the radiuses and factor of pi are just constants, so they're going to cancel out. And then you're just left with a half divided by 3/4. Well, of course, we know if we divide two fractions, we take the first fraction multiplied by the reciprocal of the second fraction, so we get a quarter times 4 over 3. And this becomes 4 over 6, which simplifies to 2 over 3. And we've got an answer for that, which is C. So therefore, our final answer equals C. Thanks for watching. Don't forget to subscribe. You can check out my other videos on this page. And also, if you've got any questions or any video suggestions, just leave a comment down below.